we go. So, the first example we're going to do, nothing new except for the base. This is base e. So, when we're solving exponential equations, we're going to have to first make sure we're in exponential form. So anytime we have anything extra, we have to get rid of that extra. So take a moment, write down the notes, and then we'll solve this one together.
Is that -4?
It is. I left the pen in the wrong spot. Alright, so we have e to the 2x minus 4 equals 6. This is an exponential equation because we're solving for the exponent. But before we solve for the exponent, we have to make sure it's in exponential form, where we just have a base raised to an exponent equal to an answer part. So in this case, what's got to go? The 4. Very good. So we will add 4 to both sides. And when we do, we now have e to the 2x equals 10. Now, whenever you solve for an exponent, you use a logarithm. So in this case, we would take the log of both sides. But when it is base e, instead of common log, we use natural log. So what we'll do is take the natural log of both sides. Now, we're going to use our properties of logs, which states that this exponent can be rewritten as multiplication and now this really nice thing happens. We have natural log of e right here, and natural log of e is 1. So that's like multiplying by 1. And multiplying by 1 does nothing. It's like it's not even there. So what we have left is 2x equals natural log of 10. And so we would divide by 2, and we get x equals natural log of 10 divided by 2. And this is the exact answer. Okay? So now let's find the approximate, which is generally what we ask for. So we'll do natural log of 10. Close your parentheses.
Wait, how do you do natural log?
It's
Okay.
right below log.
Oh, cool.
That is a good question. Natural log is located right below log on your calculator. Very good. 1.15 is our approximate answer. So you go ahead and give me to the nearest hundredth. Sounds good. Okay, everybody punch. Make sure you understand. Make sure you get the same answer. If you have any questions on how to use your technology, let me know. If you don't, then you try example 2. That's right. And so when you put it in your calculator, close your parentheses right here. And then you put 5.
So you weren't just add it on automatically and exact.
When you add it, it ends up being natural log of 10 plus 5. But when you put it on your calculator, close those parentheses around the
So you
2.
can't just combine it to 15. Okay.
Yeah. Very different in value. Okay. So the first thing we have to do is rewrite this equation so we get it in exponential form. So it's e to the x minus 5 equals 10. And then we're solving for an exponent, so we take a logarithm. But because it's base e, we're going to choose natural log, because that is the logarithm that we use with base e. So this becomes x minus 5 equals times natural log of e equals natural log of 10. Well, natural log of e has a value of 1. So it's like it's not there. And then we just add 5 to both sides. And so our answer would be natural log of 10 plus 5. You might want to type it in like this, 5 plus natural log of 10, so that you don't accidentally do the 10 plus the 5 first. You know what I'm saying? So, 5 plus natural log of 10, and you should get approximately 7.30. Questions about example 2? Cool. All right, so example 3. It's an exponential equation. We are solving for the exponent. It is base e, but there's extra stuff. So, what has to move? The 4. How do we get rid of 4? Divide by 4. And so now we just have the base raised to the exponent equal to an answer. In this case, and in all the cases today, the base is e. So when our base is e and we go to take a logarithm, we will always choose natural log. The exponent comes out in front. Natural log of e has a value of 1. Multiplying by 1 doesn't change anything. So to solve, we would just divide by 5. So our exact answer would be natural log of 6 divided by 5. And so our approximate answer would be 0.36, 36 hundredths. You're right, that would be 4 times. Okay, so this negative is like negative 1 times e to the 2x plus 3. Do you guys understand that when it's a negative? It really means negative 1 times that. Now, it would be different if there were parentheses there, but there weren't. So it's negative 1 times e to this power. So this is kind of grouped together, and then the negative 1 is times that. All right, so what's got to go first? The 4. And now what do we do? Divide by negative what? Now, you're totally right, Davis. And I hope that all of us get right here and see that there is no solution. The reason there is no solution, is it possible to raise this positive number e, 2.71828? Is it possible to raise a positive number to a power and get out a negative number? No. But let's say you're just cruising through your homework or plowing through a test and you just keep going. If you kept going, your calculator is going to help you out. It's going to say, hey buddy, this doesn't work. Punch in natural log of negative 15 and see what happens. It won't go any further. It says error. A log of a negative number is not defined. So it gives you another hint. You can't do this. There is no solution to this problem.
So log of a negative is no solution.
Now, yes, whenever we take log of a negative number, there is no solution. Is it okay to have a negative exponent? Yeah. A negative exponent is okay because that just turns it to a fraction. But we can't have log of a negative number. So in this case, no solution. If the x was negative, yeah, we could keep going. Okay. All right. Now, this is where we started to struggle on our last test. So, I want to remind you of the rules here because the rules are not going to change. We have two situations when we're dealing with equations that have logs. If we have logs on one side and only one side of the equation, if we need to condense them, we do, and then we switch forms. This is what got us on our test. Those middle four on the front. 5, 6, 7, 8. It was bad.
Honestly, so bad. Like,
Okay? Now, if we have logs on both sides, we don't have to switch forms. But if there are multiple logs on one side, we have to condense those so that we have a log equal to a log. And then we just set the answer parts equal and solve. So those are our two possible scenarios. Logs on one side, logs on both sides. And we approach them differently. So number 4. Do we have logs on one side or logs on both sides? One side. So we condense and switch forms. So when we condense this side, it becomes log of 4 times x plus 1, because addition can be rewritten as multiplication, equals 3. Now we switch forms. Yes, sir.
what if there's a negative in the exponent?
It's okay to have a negative exponent. It's not okay to have a negative log. All right, so when we switch forms here, to switch forms, we go, what is the base? What is the exponent? What is the answer? Because it's base raised to the exponent equals the answer. If it's natural log, what is the base? E. So it becomes e to the, what is the exponent? 3. Equals the answer part. 4 times x plus 1. Now, we could distribute this 4. Certainly, that would work. Or we could divide by the 4. That would also work. And you can pick your method. If we distribute the 4, which is probably what many of you will do, it would look like this. And then you would subtract the 4. And then you would divide by the 4. So your answer would either be this, or if you had divided by the 4 first, it would be this. But aren't those two the same thing? So you could write your answer like this or this if it's exact. Now, if I ask for a decimal, you would do the second and ln button on the calculator because that automatically pops up base E. Second ln to the third divided by 4 minus the 1. And so the approximate answer would be 4 2/100.
So x would, well, above, before we get that, x would equal 3, E3
Yeah.
over 4x.
How did I do the decimal part?
Yeah.
All right. And then that was divided by 4, and it's minus.
I don't know how to do that either, but I think my calculator does it.
No, that was fine. Fine. Okay. To the third, minus 4. Enter. Divide by 4.
Well, I wasn't, that's clear.
Okay. All right, example 5. Subtraction is rewritten as what? Division. So when I condense this side, do I have logs on one side or logs on both? One. So when I have logs on one side, what do I do at this point? Rewrite. Switch forms. So it becomes, what's my base? E. What's my exponent? 0. And the answer part is x minus 1 over 3. Now, e to the 0 you could do on your calculator, but any number raised to the 0 power except 0 to the 0, any number other than 0 to the 0 power is 1. Now, when we have a fraction, we always multiply by the denominator. And say we get 3 equals x minus 1, so 4 is the exact answer for x. And there is no approximate, we just have the exact. Make sense? Okay, last one we're going to do together, example 6. Both sides, that's right. This one has logs on both sides. So, when we have logs on both sides, we condense both sides and then set the answer part to equal. So in this case, the only thing we can do with the left side is take that 2 and let it become an exponent. Now the right side, we have addition of logs, so we can rewrite that as multiplication. So we have logs on both sides, and we have condensed them. So at this point, we set this answer part equal to that answer part. Because the only way this can equal this, with them both being natural logs, is if this answer is equivalent to that answer. So we set x squared equal to 4x plus 32. And we have a quadratic. And a quadratic must equal 0 to solve. So when we move the 4 and the 32 over, it factors so nicely. What can you multiply to get negative 32? That you can add to get negative 4, negative 8, and positive 4. So, what value of x would make this factor equal to 0? 8. What value of x would make this factor equal 0? -4. Do they both work?
Yes. Yeah. They do.
-4.
No, it gets rid of it.
And this, if we plug this back into the original,
Can't take that.
We gotta do.
that part would be undefined the way it's written.
I thought it's the square view.
Is pin rods in reverse for the solving part of this?
For factoring?
No, for the, just like the solving part of this.
Yeah.
Just
What
like
you undo?
The opposite.
Uh-huh.
Yes.
What if the 2 happen to be a 3?
If this had been written as this line, then they actually would both work. But the original problem wasn't.
So you always have to go to the back to
Isn't
the
it the same
original.
thing, shred differently?
Okay.
It is, but different.
I'm sorry. Can you explain me why it's just me?
Why it's just
Yeah.
8? Because if we took this -4 and plugged it back in here, this would be undefined, the way the problem was originally written. Okay? All right. So you guys get started on those. I'm going to try to finish up the few that I haven't finished. I can let you see them, but I can't let you have them.